So today I will be discussing ellipsometry, which is an optical analytical technique which is used to measure the properties of thin films such as thickness, refractive indexes, and various other optical properties. It measures the changes in polarization of light after reflecting off a sample surface. So when a linearly polarized light falls on a sample surface, it reflects, giving a elliptical polarized light. Ellipsometry is also surface sensitive due to its ability to measure polarization at extremely accurately. So here we can see the various types of polarizations visually. The linear polarization The linear polarization is the first stage of the ellipsometry. Circular polarization is just given for example, and our main focus is elliptical polarized light, which we get after uh, as a result. So, as an experimental setup, we'll need a light source which emits polarized light. The light interacts with the sample surface. Reflected light is analyzed to detect the changes in polarization and the data processed to extract materials properties like thickness and refractive index. So in here we can see the linearly polarized light falls on a sample, and then it gets reflected, giving us a phase difference and a path difference, which we find out, which we use to find out uh, thickness and refractive indices and other optical properties of light. So the main working principle for ellipsometry is that it it measures two parameters, which we name as psi and delta. The psi is related to the amplitude ratio of the reflected light. As we see here, the change in the amplitude ratio of the ESI and EPI in the P1 of the linear polarized light and of the elliptical polarized light, there's a difference. That is the amplitude ratio, that is the psi, and delta is the phase difference of the elliptical polarized light. So by analyzing these values, we can determine the optical constants and the thickness of the film. But here the problem is that the ellipsometers usually do not tell us directly the value of psi and delta. Instead, they tell us with various functions of delta and psi. So in the various functions of delta and psi, we get namely measurable quantities, namely IS, IC, and IC dash, in which IS is equals to sine 2 phi and sine delta, IC equals to sine 2 psi and cos delta, and IC dash is cos 2 psi. When we combine when combined, IS and IC provide an accurate measurement of delta over the full range of 0 to 360 degree, and IS IC dash provide an accurate measurement of psi over the full range of 0 to 90 degree. So here we can see the ellipsometry parameters, psi and delta. When we find them, when we calculate them, then we can find the uh, of film thickness and optical constants using the Fresnel equations. And this is the Fresnel equations. Here we can find the value of n2 and n1. So the types of ellipsometry, we'll see that there are various types of ellipsometry, but here are some of them. Spectroscopic ellipsometry, it measures the changes in light across a range of wavelengths. Uh, Imaging ellipsometry provides spatial resolution for surface analysis. The in situ ellipsometry is used during the material deposition or other dynamic processes. So the main application of ellipsometry is a thin film characterization, the thickness, refractive index, and absorption properties. It is mainly used to calculate the thickness of films which are very thin, usually in nanometers. Other uses are in semiconductor industries, monitoring layer growth and materials. They are also used in biotechnology, studying protein and biomolecular adsorption, and surface science, investigating coating and oxidation process. So from here we can observe that ellipsometry is always used for uh, really nano level particles, very small particles. It is not even used for micro level particles. The, some advantages of ellipsometry is that it is a non-destructive optical analytical technique. It does not changes the sample as we just perform a reflection on it. There is nothing else. A linear polarized light is falls on the surface and it is just reflected over it, and nothing else. It is high sensitivity. It can detect sub-nanometer changes in thickness. That's the main advantage of the ellipsometry, which is why we use to calculate thickness. Its versatility. It is applicable to metals, dielectrics, organic films, etc. It is also used for real-time monitoring. It is useful in dynamic processes like deposition. So, from this PPT, we can conclude that ellipsometry is a very powerful optical technique which is used for thin film analysis. Its application ranges from material science to semiconductor industries to biotechnology to various other industries. Also, the non-destructive nature and the high precision make it a widely used tool. Thank you.